What rule did Marie and Luttrell use? Which rule did Marie and Luttrell use? So let's go back to our rules here. Which rule looks the most similar to the rule that Luttrell and Marie used? Is it rule 1, 2, 3, 4, 5, 6? Show with your hands which rule is the most similar looking to Marie and Luttrell's.
2, 2, 2, 2, 2.
2. Okay, so rule 2. So what are we doing in rule 2? When you're taking a power, a base with an exponent to another power, what do you do with the two exponents?
Multiply them?
You multiply them, okay. All right, so can we agree that 3 over 2 is equal to 1/2 times 3?
Yes.
Okay, so that's the rule that they're using, okay. So 16 to the 1/2 power is 4. Yeah, it's the square root of 16. 4 to the third is 64. And Luttrell did the same thing. He just, instead of putting the fraction inside the parentheses, he put the fraction on the outside. But it's the same rule that he applied, right? Okay. Jacayla did something different. She did some addition. Which rule did she use? 1, 2, 3, 4, 5, or 6? Which rule? 1, 2. Number 1. She used number 1. So she broke the fractional exponent into an addition problem and then solved it using that way. Are all 3 of them right?
Yes.
Yes, all 3 are right. Okay. So which method did you find the most easy to understand?
No, we don't know.
Marie, Luttrell, or Jacayla? I can't hear you. Can you say it a little bit louder? Okay, so you like Luttrell's method better. Okay. So let's call this method 1, method 2, method 3. Which method did you like the best? 1, 2, or 3? Show with your fingers. 1, 2, or 3.
Mostly 1. You got a 2, couple 2s, and a 3.
Okay, mostly 1, so we're going to go with 1. So, hey, Miles, how are you? Miles,
Pretty good.
Pretty good. Could you show us how to apply Marie's method so that we can break this problem 2a apart into something a little easier to follow?
Yeah, so what I did was you take, since it's 5/3, you would go 8 1/3 in parentheses to the 5th power.
Okay.
And then that would equal, then you do 8 to the 3rd, which is 2.
8 to the 1/3 is 2, okay.
And then to the 5th power, which would be 32.
All right, that seemed to be fairly straightforward. All right, we need a girl this time. Let's break 2b apart so that we can find an answer without using a calculator. Are there any female volunteers here? Allie.
So start with 125 to the 1/3 power again.
Okay.
And then outside the parentheses would be the 4th power. And then 125 to the 1/3 power is 25. And 25 to the 4th power is 3,125, I think. But I'm not sure because I didn't do this problem.
Well, I'm sure that we can get someone to multiply 25 times 25 times 25 times 25 really quickly. So 25 times 25 is 625. So 625 squared is
15,600.
15,625.
Times 25. 3.
So 625 squared.
Yep.
Sorry, 25. So 25 times 25. 625. We square it. So we get.
Yeah, I completely messed it up, but
That's okay. 39,000. The 390,625. All right. So for question B1, which rule are we going to be using? Are we going to be using the first, second, third, fourth rule? Which rule will we be using for B1? Which one looks the most similar to our rule?
No response. Oh, Max says 3. He's the only one who's responding.
Max says 3. All right.
Owen says 3.
So in this problem, we have the same base and we have different exponents. Which rule has the same base but different exponents?
3, 3, 2, 3. Owen says.
Well, so rule 2 has an exponent outside of the parentheses. Do we have an exponent on the outside of the parentheses in question B1A? Okay. In rule 3, we have different bases. We have an x and a y, but the same exponent. So do we have the same exponent but different bases here? No. We have the same base and different exponents. Which rule has the same base but different exponents? We've eliminated 2 out of the 3, and the other one clearly has fractions.
Still saying 3.
Okay, it's definitely number 1 because the bases are the same, but the exponents are different. What will we do with the exponents if we're multiplying the same base? Add them. We will add them. Okay. So, what is 4 to the 3/2 power times 4 to the 1/2 power? What will I do with the exponents?
Macy.
Macy?
You're gonna add them to get 2 for the packet.
Okay, because 3/2 plus 1/2 is equal to 2. And what is 4 to the 2nd power?
It would be 16.
All right. For question B1b, we have the same exponents, but different bases. Same exponents, different bases. Which rule has the same bases, the same exponents, but different bases? Which rule has the same exponents but different bases? Nolan?
3.
Rule number 3. Excellent. Rule number 3. Okay, so in that case, in rule number 3, what do we do with the 2 different bases? We multiply them. Okay. So, what will we do for question B?
Multiply 4 and 2. Yeah. You get 8.
So we get 8 to the 1/3 power, which is 2. What will we do in question C? What will we do with the exponents? So I'll send them outside if you want to keep them. What will we do with the exponents in question C? Ray, you can help out too. When we are taking we'll multiply them, okay? So what is 5/3 times 3? 15/3.
15 thirds or 5.
Or 5. 15/3. 15 divided by 3 is 5. I know you want your break, but I want it too. We've got to at least finish what everyone else is finishing. All right, so question D. What will I be doing with the exponents in question D?
Subtracting them?
We'll subtract them, because when you multiply with the same base, you will subtract the exponents. So we'll get 25 to the 3/2 minus 1/2 power. What is 3/2 minus 1/2?
1.
1. So we get 25 to the first, which is equal to 25. All right, so your homework tonight, we're going to have to add a little bit to it. You're going to have to also finish question E. And I will provide a summary video for question E as well. All right, are there questions on how to apply the rules of exponents using fractional exponents? Again, the rules of exponents are a mandatory, you must know them. Applying it to fractional exponents, you may not have to be able to apply fractional exponents until you're into high school. All right, have a great break, and I will see you tomorrow.
Thank you.